Okay, now let's look at a problem involving gravitational potential energy. And actually we have three different scenarios, actually one scenario, but we're looking at gravitational potential energy relative to three different points in this problem. So let's go ahead and look at our problem, and we say we have a 2 kilogram ball, and that tells me that the mass of the ball is 2 kilograms, and it's attached to a ceiling by a 1 meter long string. The height of the room is 3 meters. And then it asks, what is the gravitational potential energy? So I'm going to go ahead and do that in pink. What is this? Associated with the ball relative to each of the following. So it gives me some scenarios here, or some three different things that I want to look at. So let's go ahead and label my picture that I have right here. I have my ceiling, my floor, and my ball. I know that the distance from the ceiling to the ball is 1 meter. That's 1.00 meters. Right? I also know that the distance from the ceiling to the floor is 3 meters. So that's 3.00 meters. And so that means that the distance from the floor to the ball is going to be 2.00 meters, because 2 and 1 make 3. So once I have all my parts labeled, I can now start calculating my potential energy, my gravitational potential energy. And so just so we know the equation for that, my gravitational potential energy equals the object's mass times the acceleration of gravity times the height. Now, in this case, G is going to be a positive 9.81. Energy is a scalar, so we don't really have a direction for it. Instead, we are just going to take the scalar form of G. We don't need to know that it goes down, so we're just going to use it as 9.81. So in order to calculate A, so let's look at problem A. The ceiling, reference to the ceiling. So that means that my ceiling is my 0 mark. So if my ceiling is 0, so if this is 0, this line right here is 0, then the ball is going to be 1 meter down, or -1 meters. So my height is going to equal -1.00 meters. All right. My mass equals 2.00 kilograms, and G equals 9.81. And I want to know good old PEG, my gravitational potential energy. So using this equation up here, I'm just going to go ahead and plug in, because I've already solved for PEG, or for my potential energy gravitational. So I get P, good old PEG, equals 2.00 times 9.81 times 1.00, and that's a negative. Okay, now I'm going to go ahead and pull out my calculator and do some calculations. So give me a second and I'll pull it up here. And we'll move it out of the way. And then now I'm just going to type it in. 2.00 times 9.81 times -1.00. And I get, let me double check that real quick, make sure I did it correctly. I'm not used to this calculator. 2 times 9.81 times a -1.00. So you look at it, it's subtracting, it's not timesing. So I need to make sure I times it by, let's go ahead and hit in 1.00 and hit this negative sign, equals 19.62. So my answer for this is that my gravitational potential energy for this first scenario equals -19.62 joules. All right, and let's go ahead and highlight that so that we have our answer highlighted. There we go. I guess I just need to make my highlighter a little bit thicker And then I don't have to keep doing all this nastiness with the messing of trying to color it in. Okay, let's look at this second scenario, B. So we'll do that right here. B, with the floor. So with the floor, my height is actually going to be the floor is 0, so my height is going to be a positive 2.00 meters. All right, G and M stay the same, so I'm just going to go ahead and plug that in. PEG, good old peg, equals 2.00 kilograms times 9.81 times 2.00 meters. All right, let's go ahead and bring up the calculator again. And let's move it out of the way. And we'll go ahead and type it in. Clear. And I get 2.00 times 9.81 times 2.00, and I get 39.24. So peg equals 39.24. Now, I didn't do this on the last one, but we need to really look at significant digits. In this case, I have 3, I have 3, I have 3. I really need to keep 3. So peg equals 39.2 joules. And let me go ahead and highlight this. See if I can't increase the thickness a little bit. There we go. To that. I can probably go a little thicker on the next one. There we go. So now, let's do the final scenario. Pick out my pen again. And C. And C is at a point that is at the same elevation as the ball. So that means that this point right here is 0. So my height equals 0. Hopefully you can already see that once I plug this 0 into my equation, MGH, well then H is 0 and all that other stuff multiplied by 0 is 0. And so without doing the math, peg equals 0 joules. There we go. So that's the answer to C. And that's how you use the gravitational potential energy equation.